Next, our topic is the solubility. Solubility means the maximum amount of solute can be dissolved in a specified amount of solvent at a specified temperature and pressure is known as the solubility. For example, if you take the one beaker, so in this beaker, first you can add the solvent. So first we have to add the solvent, and to this solvent we have to add the solute. We have to add what? Solute. So in a specified, for example, in 100 ml of solvent, if 1 gram of solute is dissolved, that is the solubility of this solute. Solubility means the maximum amount of solute can be dissolved in specified amount of solvent at a specified temperature and pressure is known as the solubility. So based on the solubility, the substances are classified into three types. Those are soluble substances, sparingly soluble substances, and insoluble substances. These soluble substances are having the solubility is a 1 gram per 100 ml. Means in 100 ml of the solvent, 1 gram of solute is dissolved. Such type of the substances are known as the soluble substances. And sparingly soluble substances are having the solubility is less than less than 1 gram or greater than greater than 0.1 gram per 100 ml is known as the sparingly soluble substances. And next one, the insoluble substances, and these insoluble substances are having the solubility is less than less than 0.01 gram per 100 ml. Means in 100 ml of solvent, 1 gram of solute is soluble. Such substances are known as the soluble substance. In 100 ml of solvent, greater than the 0.01 gram of solute or less than the 1 gram of solute is soluble, such substances are known as the sparingly soluble substances. The insoluble substances are having the solubility is less than 0.01 gram per 100 ml. Now we will discuss about the solubility of solids in liquids. So solubility of solids in liquids. This affects solubility of solids in liquid is depends upon the few factors. One is the nature of solute and solvent. Second one is the temperature, and third one is the pressure. So first we will discuss about the nature of solute and solvent. In this one, the polar compounds are soluble in polar solvents. For example, if you take a sodium chloride, okay, potassium chloride, sugar, okay, so these are soluble in water. Here water is the polar solvent, and sodium chloride, potassium chloride, sugar, so are the polar compounds. Means polar compounds are soluble in polar solvents, and non-polar compounds are soluble in non-polar solvent, but non-polar compounds are insoluble in polar solvents. For example, ethyl ether is there. Ether, or simply we can take the ether, benzene, C6H6, and even you can take the acetone, CH3CO CH3. So these are insoluble insoluble in water, because these are not in a polar in nature. So non-polar compounds are insoluble in polar solvents. Here you may get one doubt. Why these compounds are soluble in water? So why not these compounds are soluble in water? Because these are the compounds can forms ions with the water. For example, you can take a HCl is the one polar compound. So this one will be split into H plus and Cl minus. And water is also having the polarity H, and here this is the water. This in this water oxygen can possess the partially negative and hydrogen can possess the partially positive. Partially positive charge of hydrogen and a negative charge of chlorine, we can get the hydrogen bond. Due to the formation of this hydrogen bond, all the polar compounds are soluble in water. And this type of hydrogen bond is not possible in non-polar compounds. For example, here benzene. So this benzene is does not dissolve in water. Here partially negative and here partially positive. And here there is no partially positive and negative charges in benzene, so that there is no formation of hydrogen bond. And simply remember, the substances which can forms hydrogen bond with water, those all the compounds are soluble in water. And which does not forms hydrogen bond with water, those are insoluble in water. And this is the nature of a solute and solvent. And next one is the temperature. So the solubility of solid in a liquid is also depends upon the temperature. So for example, if you take the one container, so in this container first we have to take the solvent, and to this solvent we have to add the solute. So after adding the solute to the solvent, this solute is soluble in the solvent. As a result, we can get the solution, means a solute plus a solvent, then we can get the solution. And if the dis, uh, dissolution process is the exothermic process, if the dissolution process is exothermic, at the time the solubility of solid in a liquid is a decreases. Means if the dissolution process is the exothermic, the solubility of solid in a liquid is decreases. If the dissolution process if the dissolution process is endothermic, if the dissolution process is endothermic, the solubility of a solid in a liquid is increases. So here exo means releasing of energy, endo means absorption of energy. So when this solute is soluble in a solvent, at the time if some amount of energy is liberated from this solution, such process is the exothermic process. In that exothermic process, solubility of solid in liquid is the decreases. And one more is, while dissolving this solute in the solvent, at the time the absorbed heat is absorbed by the solution. Such process is the endothermic process. In If the dissolution process is the endothermic process, the solubility is increases. That only I written in sentences. If the dissolution process is the endothermic, means change in enthalpy of solution is greater than the zero, the solubility of solid is increases with increase in temperature. This you have to remember. Means change in enthalpy is positive, and this is according to the Le Chatelier's principle. If the dissolution process is the exothermic, means while solute is dissolving the solvent, at the time if energy will liberated, when energy is liberated, the solubility of solid is decreases with increase in temperature. So change in enthalpy is negative. So for example, sodium sulfate, lithium sulfate, and these are the some examples for the exothermic dissolution process. And third factor is pressure, and there is no effect of pressure on the solubility of a solid in liquid, because the solids and liquids are highly incompressible. So this is about the solubility of a solid in liquid. Next, we will discuss about the solubility of gas in a liquid. The solubility of gas in liquid we will discuss. So here first, this also is depends upon the few factors: nature of solute, nature of solvent, temperature, and then pressure. So these are the four factors can influence the solubility of gas in a liquid. First we will see the nature of the solute. Means gas in a liquid means the solute is present in the form of gaseous state and the solvent is present in the form of liquid state. So first one is the nature of solute. Highly liquefiable gases are more soluble in liquid. So highly liquefiable gases are the temporary gases. For example, here ammonia, carbon dioxide, sulfur dioxide, and HCl. These are the temporary gases. Temporary gases. All these temporary gases are highly soluble in water. Even oxygen. So oxygen is also soluble in liquid, that too in very small extent. Due to that, only aquatic animals and aquatic plants are survive in cold water very comfortably. That we'll discuss later. And next one, the temporary gases are more soluble in liquid, and permanent gases like helium, nitrogen, oxygen, hydrogen are permanent gases, and these permanent gases are very less soluble in liquid. And so that only hydrogen, nitrogen, helium, oxygens are never convert into liquid state. And this oxygen, ammonia, carbon dioxide, sulfur dioxide, and HCl. And along with this, you can take even methane also. So these are the temporary gases. Temporary gases are easily liquefiable, and these easily liquefiable gases are having more kinetic energy or critical temperature. So, or more kinetic energy and critical temperature. Means the gases which are having more critical temperature, those are more soluble in liquid. For example, if you take methane and ammonia, so methane is having a less critical temperature, and ammonia is having more critical temperature. Means the gases which are having more critical temperature, those are more liquefiable gases. More liquefiable gases are more soluble in solvent. This is about the nature of solute. And next one is the nature of a solvent. So the solvent which can form hydrogen bonds with the solute, those are more soluble in solvent. And here, for example, HCl is there. HCl is the one gas, and this gas is soluble in water. Here you can take the water. So in water, this is a partially negative and this is the partially positive, and this is a partially negative and this is the partially positive. Whenever this HCl gas we are adding to the water, in HCl, partially negative charge of chlorine can form hydrogen bond with a partially positive charge of water. So whatever the gas molecules can form hydrogen bond with the water, those all the gases are soluble in liquid. And next one is the third one is the temperature. The solubility of gas in a liquid is decreases with a rise in temperature. For this also you can take, so in one container you can take the solution. So this solution contains a solvent, and gas is the solute. Gas is the solute and solvent is the liquid. Now we got the solution. Now from downside you can increase the temperature. When the temperature is increases, these gas molecules can absorb the energy, and as a result these gas molecules can possess more kinetic energy. As a result of more kinetic energy, these gas molecules will escape from the surface of the liquid. So it indicates as the temperature is increases, the solubility of these gases in liquid is decreases. And here, due to this reason only, all the aquatic plants and animals are more comfortable in water, in cold water. So in cold water temperature is the less. When the temperature is the less, the solubility of oxygen in water is more. When the solubility of oxygen is more, aquatic animals and plants can get a sufficient amount of oxygen. But in case of warm water or hot water, so temperature is a more. When temperature is the more, the solubility of oxygen in a liquid is decreases, so that aquatic animals and plants cannot possess a sufficient amount of oxygen to survive. So that aquatic animals and plants are more comfortable in cold water rather than the hot water. And next one is the pressure. So the solubility of gas in a liquid is increases with the increase in pressure. So here you can take, in this one you can take first the solvent. The solvent is present in the liquid state. Now here you can take the gas molecules. So gas molecules are present on the surface of this solvent. Now here you can take the one piston. Okay. Now, with the help of this piston, if we compress these gases, all these gases will enter into the solvent. Means as the pressure is increases, the solubility of these gases in the liquid is increases. This you have to remember. Okay, and to give the relationship between the solubility of gas in a liquid, the scientist Henry gave the one law, that is the Henry's law. So according to Henry's, the solubility of gas in a liquid is directly proportional to partial pressure of gas present above the surface of liquid. The partial pressure of the gas present above the surface of the liquid, or the partial pressure of the gas in vapor phase is directly proportional to mole fraction of the solution. So here partial pressure P is directly proportional to mole fraction of the solution, and here P is equal to kH into X. Here kH is the proportionality constant or Henry's constant. Different gases, different gases has different different kH values. Different gases are having the different kH values. So higher the kH value, higher the kH value, lower is the solubility. Lower is the solubility. This you have to remember. This is a very important point. Means higher the KH value, the solubility is lower. For example, if you take the nitrogen and nitrogen and oxygen, so out of these two, this nitrogen is having the KH value is less, and this oxygen is having the KH value is more. Then out of this, which is more soluble? So higher the KH value, lower is the solubility, and less is the KH value, more is the solubility. So that nitrogen is more soluble than the oxygen. Okay. So here we have to take the solvent, and then here solute, and this solute is present in the gaseous state, and this one how to keep in a closed container. So these gas molecules can collide with the walls of the container. At the time it can exert the some pressure. That pressure is known as the vapor pressure. So this vapor pressure is the pressure of gases, so that is known as the partial pressure. So the partial pressure of these gases over the surface of the liquid is directly proportional to mole fraction, is directly proportional to mole fraction. So already we know about the mole fraction. Means as the number of moles of gases increases on the surface of this liquid, the partial pressure of this gas is also increases. So next one is the applications of Henry's law. So, to increase the solubility of carbon dioxide gas in a soft drinks or in a soda water, the gas should be sealed under high pressure. So, we know that in cool drink shops, most of the cool drinks we will get in cool drinks. If you once open the cap, you will get the gas. That gas nothing but the carbon dioxide only. To increase the solubility of that carbon dioxide in aerated water, that gas should sealed at a high pressure. Next, second application is the scuba divers must cope with the high concentrated dissolved gases. Means the scuba divers will go in depth of the sea. While going in depth of the sea, the pressure will be increases. When the pressure is increases, whatever the gas molecules are present in the body, those gas molecules will convert into liquid state. As a result, there is no gas molecules in the body. And when that scuba divers are coming towards the surface of the sea, at the time what the pressure is decreases, and whatever the gas molecules are earlier converted into liquid, then liquids are converted into gaseous state while they are coming towards the surface of sea. So at the time there is a possibility to fracture the bones, and there is a possibility to damage the muscles and even all the tissues. So to avoid that condition, the such a medical condition is the bends. To avoid the bends, they should carry the highly dissolved gases like 11.7% of hydrogen, 56.2% of nitrogen, and 32.1 percentage of oxygen. So the scuba divers can carry this gaseous mixture to avoid the bends. And third application is at high altitudes, partial pressure of oxygen is less. So when the partial pressure is less, the amount of oxygen at high altitude is less. As a result, who are living at high altitudes or the mountain climbers, becomes very weak and they are unable to think properly. Such a medical condition is known as the anorexia. So, limitations of Henry's law. Uh, to apply the Henry's law for the gas in liquid, the pressure is not too high. When the pressure is high, the gas is completely soluble in a solvent. So that pressure should not be high. Temperature is also should not very low. Gases should not soluble in solvent completely, and gas molecules does not form ions with a solvent, and gas molecules neither associate nor dissociate with a solvent, means it does not form the hydrogen bond. And next one is the concept of vaporization. So before discussing about the concept of vaporization, we will discuss about the dissolution process and crystallization process. Now take the one container. In this, take the solvent, and to this you can add the solute. So when we are adding the solute to the solvent, some solute particles dissolved in the solvent, and it can increases the concentration, and this process is known as the dissolution process. For example, here 1 kg of solute is there. Out of this 1 kg of solute, if 250 grams of solute is dissolving in the solvent, and as a result the concentration of this solution is increases, that process is known as the dissolution process. And next one, the crystallization is there. Some solute particles, for example here one solute particle, here solute, and these are the solute particles. So some solute particles will collide with another solute particles, like this, means this is a solute particle is colliding with another solute particles, and these solute particles will separate from the solvent, sorry, separate from the solution. That process is known as the crystallization process. Means whenever we are adding the solute to the solvent, two process will take place. One is the dissolution process, another one is the crystallization process. Dissolution means the solute dissolved in a solvent. As a result, concentration of the solution is increases. The process is known as the dissolution process. And some of solute particles will collide with another solute particles, and that solute particles will separate from the solution, and the process is known as the crystallization process. And whenever the dissolution process becomes equal to crystallization process, at the time no more solute is soluble in the solvent. Such type of the solutions are known as the saturated solutions. Saturated solution means what? No more solute can be dissolved in the solvent at a given temperature and pressure is known as the saturated solutions. And these saturated solutions are observed at equilibrium. Means whenever dissolution process is equal to crystallization, that position is a equilibrium position. So in this equilibrium position, we will get the saturated solutions, and even unsaturated solutions are there. Unsaturated solutions means more solute can be soluble at a given temperature and pressure is known as the unsaturated solutions. And one more is a super saturated solutions, means still more solute is soluble with increase in temperature or pressure is known as the supersaturated solutions. For example, here take the 1 liter of solvent, to this 1 liter of solvent, add first 1 tablespoon of salt that is easily soluble, and add 2 more, add that also is soluble, and add the 5 tablespoons of salt. So at that condition, that solute is insoluble in solvent. Such condition is saturated, and dip the 1 spoon and stir that solution. Means still some more solute is soluble. Such solutions are known as unsaturated solutions. Now you can increase the temperature. Still, total complete salt is soluble in water. Such type of solutions are known as supersaturated solutions. Now we can come to the vapor, mm, vaporization, evaporation, rate of vaporization, rate of condensation, and vapor pressure. So here vaporization means the vaporization